The Amazon rainforest is one of the most important ecosystems on Earth. It holds millions of species, regulates the global climate, and supports thousands of communities. But today, it faces serious threats. Deforestation is happening faster than ever, not just from agriculture, but also from urban expansion, infrastructure projects, and the increasing effects of climate-driven drought. In this documentary, we will explore the problem of forest loss in the Amazon by focusing on one key issue. There is a lack of integrated research on how different factors like cities, roads, and drought work together to cause deforestation. At the same time, the roles of policy and socio-economic pressure are often ignored. To understand and solve this complex issue, researchers now use tools like remote sensing and geographic information systems. These technologies help monitor land changes from space and analyze the impact of human activity on forests. The title of this documentary, When Growth Consumes the Green, refers to how economic development in the Amazon, especially urban growth and infrastructure, is now one of the leading causes of deforestation. While agriculture and logging have long been problems, recent studies show that roads, fire, and unregulated development are just as harmful, sometimes even more. For examples, a study in Altos, Brazil, found that forests were being cleared near roads not just for farming, but for land speculation and cattle pasture. Another study shows that forest loss can change the local climate, especially rainfall. Less forest means less rain, which leads to more drought and more fires. This becomes a dangerous cycle. It begins with deforestation, drought, fire, and more deforestation. Now, let's look at some of the main challenges based on recent research and why this issue is harder to solve than it may seem. First, in a 2024 study by Narayanan and colleagues, scientists used satellite data to track sediment levels in rivers. They discovered that rivers only showed serious impacts after more than 5% of the land was deforested. And in many cases, the effect appeared 1 to 2 years later. This means damage from deforestation might not be immediately visible, making it harder to take early action. The study also pointed out that many rivers in the Amazon don't have enough long-term data, especially during the rainy season. Cloud cover and poor monitoring in remote areas limit what we know. Another issue comes from Silva, who studied the impact of deforestation and fire on rainfall and temperature. They found that these activities can change local weather, and yet most policies do not consider this. Fires are not always natural. They are often set on purpose to clear land. Finally, the study in Altos showed that roads and land speculation are major causes of deforestation. Fires usually start close to roads and then spread into the forest. But many of these fires are not tracked or prevented. Across all these studies, a common problem appears. Data is incomplete, research is often separated, and the connections between human activity, climate, and deforestation are not fully understood. This is why GIS and RS tools are so important. They allow researchers to combine data from different sources such as land cover, fire maps, and rainfall to get a clearer picture of what's happening and when action needs to be taken.
In case study 1, this study explored how deforestation in the Amazon basin from 2001 to 2020 affects sediment level in major rivers. With limited field access and vast terrain, researchers use satellite imagery and GIS to map deforestation and track sediment concentration. They discovered that in areas with heavy deforestation, sediment level rise within a year, while in less disturbed zone, changes are delayed by 1 to 2 years. However, significant effects only occur once deforestation passes a 5% threshold. This lag makes it harder to detect early damage, which complicating timely intervention. Cloud cover and remoteness limit long-term monitoring, especially during rainy seasons. Despite these challenges, remote sensing and GIS remain essential tools for analyzing human impacts on rivers and shaping sustainable land use policies to protect these ecosystems. Second case study. This case study looks at deforestation and forest fire in the central Brazilian Amazon, where extreme drought, often driven by El Nino, make forests more fire-prone. Fires mainly occur during these dry periods and are closely tied to human activity, especially land clearing for agriculture. Deforestation is concentrated near rivers and roads, while indigenous lands act as natural fire breaks. Using 31 years of Landsat and resource imagery, researchers map burn scars with the delta normalized burn ratio, even detecting delayed fire impacts. GIS tools layered fire, water, land use, and deforestation data to reveal patterns shaped by human access and climate. This method helped to predict high-risk areas during droughts and guide targeted conservation efforts. Remote sensing and GIS are key to protecting forests in the face of growing climate and human pressures. For the third case study, the Amazon rainforest is in crisis from 2001 to 2020. Deforestation and fires have surged, especially after 2019, which raised the land temperatures and reduced the rainfall. Roads and land speculation drive this destruction, often trigger the fires that worsen during droughts. Weak enforcement means many go unmonitored. To track these changes, researchers use remote sensing and GIS tools like Google Earth Engine and MODIS data. They map land use, monitored vegetation loss with NDVI, and link fire events with rainfall and temperature trends. Their findings show deforestation between 2016 and 2020 jumped 92% compared to the previous decade, with hotspot in Para and Mato Grosso. This shift formed a dangerous cycle like less forest, more heat, and less rain. The study highlights the urgent need for stronger policies and improved monitoring to protect the Amazon. Between 2001 and 2020, deforestation and fires have intensified, disrupting rainfall, raising temperatures, and increased the sediment in rivers, especially in the eastern Amazon. Even protected indigenous lands are feeling the pressure. Through 3 case studies, our research shows that these changes are reshaping the region's climate and ecosystem. Tools like GIS and remote sensing are vital for monitoring this shift, but they must evolve. We need higher resolution imagery, integration with socio-economic data, and AI model to improve prediction and uncover hidden patterns. We must also consider delay environmental responses by developing real-time tracking systems. By strengthening this tool and focus on targeted insight, we can support stronger policies to protect this irreplaceable global treasure.